Hello, my name is Vasily and I'm recording this video for a brief presentation for our partner. This is our assembly site. Here I can show you separately the core, what's inside the ultrasonic reactor. I will briefly explain how does it works and show you the examples that we have in our laboratory. At first glance, it may seem that this is just some piece of iron, but let's look at them in more detail. The core, the key technological element, is the set of the equipment. The first and main is ultrasonic emitter. There are several types of emitter. This is a bar type of emitter, and there are a shell type of emitter. Also, there are different type of engine, magnetostrictive and piezoceramical. The second the second element is an ultrasonic generator. Here we can see two types of generator. This is a small power, 2 kilowatt, and high power, up to 12 kilowatt. How can we affect the process? What parameter can we vary? First, we can change the amplitude, of course. Second, we can change the frequency. Also, we can change exposure, and we can change external pressure, make additional high pressure to the chamber, and change temperature of the process. And also we can combine different modes simultaneously. Let's turn to the first type of flow-through ultrasonic reactors. These are high-amplitude reactors based on the emitting bar. This is the titanium bar. The principle of action is a punch effect. The feature of our equipment is the high amplitude of the working area of the instrument. At least 100 micron we can get on this tool. Here inside inserted the same tool. And 100 micron, I mean in liquid. It is this tool. It's made of special titanium alloy that has undergone structural processing. The bar of special shape on the one hand and the ultra-fine grained structure of titanium on the other hand allows us to reach such amplitude. Reactors tuned to different modes can be plugged in series. So this is a reactor with a case. This is the case. This is input. Here is output. The presented model differ in frequency and power. Some of them, beside cavitation, creates a turbulizing effect. For example, these two type. Both magnetostrictive and piezoceramic transducers. This is piezoceramic, and this is magnetostrictive transducer. Here is piezoceramic too. So both types are used. There are a shell type. Also, what I would like to notice: work with nanoemulsion must begin with a small amplitude. Often it turns out that a low amplitude is enough. The key is that the amplitude should be evenly distributed throughout the volume of the chamber. The amplitude peak factor should not exceed 2. Reactor design should not have local amplitude maxima, otherwise the nanoemulsion will be subjected to burnout. For this work, like we're supposed to use the reactor of radiating shell stream. So this is a shell that produce radiating inside. Is like a path of a tube. This is a simple flow through emitter of a cylindrical shape. This one based on magnetostrictor. Principle of action: it is the pipe on which magnetostrictive material make presses. It stress this tube and produce linear oscillating inside. The pipe diameter corresponds to the wavelength in the working fluid at the resonant frequency of the transducer. This is a flow reactor based on piezoceramic transducer. The principle of the operation is the same. Between this one and this one is like the same. The only difference is here is magnetostrictive material, and inside this box piezoceramic. Here is a piezoceramic that acts on this tube. These designs of oscillating shell are more complex. This one and this one, called superposer. How it works? It acts like tuning fork. That used for tuning a piano. The only difference is instead of cantilever rods, there are two oscillating plates. When it works in phase, both plates create a high intensity ultrasound field throughout the chamber. So look, this is a tube, is like a chamber. It is a path of a tube armor, and here is a piezoceramic transducer fixed on this tube. And this is one side plate, and this is another side plate, and that's why it's called superposer. This superposer providing highly concentrated radiation, and this superposer provides a small amplitude, but it evenly distributes radiation throughout the volume, and the performance is achieved by means of cascading of several parts of the superposer. The special engineering elegance of this solution lies in fact that here we use their own resonant properties of the chamber walls. So this is the walls of chamber, and we use their own resonant frequency. The ultrasonic emitter, piezoceramic emitter, just swing the chamber walls at their own longitudinal oscillation frequency. The area of our scientific interest as acoustic developers is just focused on the study of vibration of linear and dull shell, like this one. So this is the main type of ultrasonic transducer that we offer to use for your work, for liquid treatment. That is all. Thank you for your attention.